Please welcome LlamaIndex CEO and co-founder, Jerry Liu.
Hey everyone, I'm Jerry, co-founder CEO of LlamaIndex. For those of you who don't know, LlamaIndex is a company or a startup focused on providing AI engineers the right tools and infrastructure to build Gen AI applications over your data. Today, my topic will be on building an advanced knowledge assistant. First, I usually ask this question, but just to get a read of the room, how many of you don't know what RAG is? Okay, so basically everybody knows what RAG is. How many of you are building with agents these days? Maybe a show of hands. Okay, so around like 50%. Yeah, and I think like this basically paints a picture of emerging LLM and AI-based architectures where increasingly the world is going a little bit more agentic. And so how do you use the power of large language models to not only just like give you simple responses from your data, but actually synthesize entire reports or solve research tasks? And so today I'll talk about what it takes to actually build an advanced knowledge assistant. The first thing is building a knowledge assistant is basically a very high level goal of given some data that you have within the organization, it could be unstructured data, structured data, semi-structured data, take in some input and get back some output. In the standard RAG setup, that input can typically be like a simple question that you ask and you get back a specific response. But in terms of more complex inputs, you might want to ask as an end user more complex questions over your documents. Have it actually produce a unit of output for you, as opposed to just generating like a small response. And you might want to actually give it more and more autonomy in figuring out how to solve tasks on its own, compared to being in the loop with it every single step of the way to, again, give back like a simple chat response. We think there's a lot of problems with just RAG as the be-all, end-all architecture for building a knowledge assistant. With a standard RAG setup, there's a few suboptimal pieces in here. The way RAG works is you do some basic parsing of your documents, and then you load and index your documents, put it into a vector database, retrieve from that vector database, like from SingleStore, and then put that into your favorite language model to generate a response. But there's a lot of holes in that architecture. The first piece is the data processing, especially if you follow the easy tutorials to set up like RAG 101, is usually not very good and not robust to different types of more complex data sources. The second is this isn't actually a very agentic setup. Given some sort of like complex question, the LLM really is only used to generate the final response and is not used for its reasoning capabilities. Ideally, given some sort of complex question you have of your enterprise data, you can leverage LLMs to reason about what is the actual like source of truth within your enterprise data, find the right information in a multi-turn fashion, and generate a final output for you. So we asked ourselves, can we do more than this? There's a lot of questions and tasks that naive RAG cannot give an answer to. This leads to hallucinations, for the end users. They are not able to get back or really trust the AI chatbot on some set of like responses. The next piece is this gives you limited time savings as the end user. If you're building like an internal ChatGPT for like your internal financial analysts or your lawyers or your sales, your customer support agents, if this thing cannot actually do more tasks for you, then it's not really saving you time. And in the worst case, it's actually wasting you time. And so we think that the promise of knowledge assistance is actually automating knowledge work. And we think that this directly translates into end ROI for the end user. So we asked ourselves, how do we aim to build something that's more production ready and a knowledge assistant that can actually truly automate knowledge and provide a lot of value? We think there's 4 main pieces here, and this goes into some of the core technical components of the architecture we think you need to actually build like a better knowledge assistant. So, if you're a developer or managing a team of developers, this basically helps you think about what are the right components of my overall stack that I should be building to basically set up the right architecture to solve these different types of problems. The first is a high quality data and retrieval layer. You need to make sure that the data processing layer actually works, that it's able to process different types of complex data, and that you're able to get back high fidelity results from that. The second piece is starting to layer on aspects of agentic reasoning. So beyond just a standard RAG approach where the LLM is just used to synthesize a response, having an agentic reasoning layer allows you to leverage stuff like chain of thought, tool use, reflection, and other concepts to actually break down complex inputs into simpler ones and be able to answer more complex user tasks. The third is an interesting one and something that we've actually started to think about recently by quite a bit, actually, from talking to a lot of enterprise developers and users, is actually making the output more sophisticated. If you use ChatGPT or Claude, you might notice, sometimes it doesn't just give you back like the chat response, but in the case of like Claude, for instance, it can actually generate a full markdown report for you if you ask it to. Or, in the case of ChatGPT, it can write code and actually execute it in a code interpreter. We think there's a lot of potential in generating more complete forms of output beyond just like the user having to interact with the chat response. Because to us, this basically means greater automation and greater units of knowledge work produced by the AI assistant. And the last piece is, besides just building out some of the core technical components, how do you actually package this up into a full stack application? So we have 25 minutes or so, and basically I can just go over some of the each of these components at a rough degree of detail. But if you're interested in any of these, we have a lot of resources within our docs, our website, and of course our different services for you to learn more. The first piece is high quality data and retrieval. Any LLM application is only as good as your data. For us, one special use case that we care a lot about is just thinking about the wide variety of unstructured files that exist within any company. Most companies have PDFs or PowerPoints or spreadsheets or Google Docs or Google Slides, and it's just kind of a mess. Most of these files are produced for human consumption and not machine consumption. And so one of the promises of LLMs is that assuming you can actually read what's actually going on within these documents, you can just throw the text into the prompt and have it understand everything that exists within your unstructured data. And so the steps needed to make this happen, we call this ETL for LLMs. It's a new type of ETL stack that needs to happen to translate your unstructured files into a format that LLMs can consume. The steps of this data processing layer include parsing, being able to parse your data, chunking, being able to split it up into semantically coherent slices, and then indexing, put it into a database, whether it's a structured database, vector database, a combination of the above. And there's actually a bit of nuances and complexities here. I'm happy to talk about that too. Only when you have clean data can you actually build something that's production quality. And one of the things we've noticed is that even for kind of state-of-the-art models like GPT-4o, Claude 3.5, when you feed it bad data, it tends to hallucinate on a lot of questions. And so this part is honestly one of the most underrated pieces of building an LLM. As mentioned, we care a lot about PDFs. If you followed our Twitter or LinkedIn, we have, I'll talk about our document parser in just a bit, but we've thought about this use case of, basically RAG or chat over your internal knowledge over in the form of unstructured files for quite a bit of time. And one thing we ran into early on is that a lot of documents are actually a little bit more complicated than just a bunch of text blocks. These documents have embedded tables, charts, images. If it's like an investor report or it's like a research paper, you're going to have a bunch of figures, you're going to have bar charts, you're going to have pie charts, you're going to have line graphs. The text might be in irregular layouts. You might have your 1-column or 2-column layouts, but then you might also have floating text boxes if it's a slide deck, and you might also have headers and footers. Users want to understand this data, or basically they want to throw all this data into an LLM and be able to ask questions over this entire data. And so far with naive solutions, oftentimes, I just got off a customer call. They basically said before using more sophisticated modules, they would just ignore the charts. They would ignore the tables. Just tell the end users you're not able to actually get back answers over this data. And we thought for a while, how do we actually fix this, right? How do we build something where you can actually unlock all the data instead of just part of it? And so the first piece that we basically worked on was a better parser. most document parsing is not very good. If you leverage an off-the-shelf parser, whether it's open source or even some of the proprietary ones, and you take in one of these tables, I know it's maybe a little bit faint, but from like a financial report, for instance, oftentimes it messes up the formatting of this table. And the issue is when it messes up the formatting, the LLMs now fail to actually understand what numbers correspond to what rows or columns. And that's exactly what leads to hallucinations. An LLM native document parser ideally has the following properties. One, it can actually parse tables into some format that LLMs can understand. Two, it can ideally parse text into semantically coherent chunks. So if you have like a multi-column format, it actually follows like the reading order instead of just going straight horizontally and kind of interjecting a bunch of text from disparate places into the same line. It can also ideally recognize where there are visual elements on the page. So for instance, like images, diagrams, and charts, put that into structured formats and return like image chunks for your multimodal RAG pipelines. And as a bonus, maybe it can actually extract out structured information from your unstructured data as well, beyond just like text parsing. Some interesting things that to think about is like, you might not actually need a lot of the properties that a traditional text parser gives you. A lot of traditional text parsers give you a lot of like JSON metadata, basically like the bounding boxes for each element, a lot of like annotations, those types of things. We found, honestly, most of these things don't really matter. You actually don't even need to return the table in like a super structured format. As long as you lay it out in the right way, LLMs can generally understand a table and basically be able to reason over it. So our first product that we built was called LlamaParse. It's an advanced document parser specifically for reducing LLM hallucinations. We launched it back in February. Since then, it's actually gotten quite big. We have like 30K plus unique users, 50 million plus pages processed. It's actually a great entry point if you're looking to even start digging into building advanced RAG over your PDFs or PowerPoints or Excel sheets. It's being used by companies from Carlyle, which is the quote here, to small startups, to everywhere in between. And it's basically a great tool to basically parse very complex documents in a variety of different domains. And whether it's a document with a very big table or a very visually rich document, for instance, like a product manual, like a slide deck, we're able to leverage both like traditional text base and multimodal models to extract this text into the right format. And even without thinking about more advanced indexing, retrieval, or agentic reasoning, it's actually a great place to get started. We basically demonstrate that with a good parser, you can actually start reducing hallucinations over your document data. The next piece here, right, and this is all just like technical concepts, right, and you can go back and translate this into tooling that you and your developer team may want to leverage to basically solve some of these use cases, is you can combine parsing with more hierarchical indexing retrieval mechanisms. So making that entire end-to-end RAG pipeline a little bit more sophisticated than just like splitting everything by like 512 tokens, putting stuff into a vector database. If you can actually parse things out and separate them according to their entities or elements, like text chunks, tables, diagrams, then for each element, you semantically preserve that entire thing, and you can extract out, say, a multitude of different representations that point to that source element. So a variety of different like text chunks, summaries that point to the underlying paragraph or table or image. And you can basically leverage more advanced indexing retrieval mechanisms so that when you ask a question, you make sure that the right elements of your page are returned, instead of just worrying about like content being sliced off because your chunking strategy was wrong. Some of the top use cases that we see that are even just basically just like this, like a RAG pipeline, right, over your data, but leveraging some of these advanced components and can really benefit from some of these like advanced parsing modules include here, financial reports, slide decks. I think that's like a huge use case that we see, like slide deck indexing, like PowerPoints or Keynote or whatnot. Another is like annual, like just general annual reports, like 10Ks or 10Qs. You can actually do the same for Excel sheets too. We have a way to parse, even pretty complex Excel sheets into well-formatted Markdown, and you can basically just stuff this into the prompt of an LLM and have it reason over that data. It works surprisingly well. And then a fourth use case, which is I'm starting to see pop up more and more, is basically parsing out like complex forms. So whether it's like a tax form, kind of like an insurance claim, a variety of like accident reports, these things I'm starting to see more and more, especially in the legal finance consulting use cases. An example of something that is another kind of a trend towards like more advanced RAG is multimodal RAG. And this is enabled by first like a parser like LlamaParse, which can return both text and image chunks. But if you have like a very visually rich document, you might actually want to maintain the document itself as a bunch of image screenshots versus a bunch of text. This is especially useful in cases where that document itself contains a lot of images or charts or diagrams, and you don't want to pre-extract the text because you might actually lose a ton of information from it if you do so. Instead, you want to just feed the image itself into the LLM at the end, along with the question. So we actually have invested a lot in helping users build fully multimodal RAG pipelines that can store both text and image chunks for use within a multimodal LLM. There's a lot of great research out there on how do you actually build a multimodal LLM or multimodal RAG pipeline. The first is you need a good parser, like LlamaParse. The second is you do need a multimodal model. The most recent models, again, like OpenAI, Anthropic, Gemini, are indeed multimodal. And also some of the open source ones like Pixtral and Llama 3.2. And then there's also kind of a variety of different types of indexing retrieval techniques that are popping up. Some of you might have heard of like Copoly, for instance, which is an open source open weight model. It basically enables you to feed in the images of a document directly and do search and retrieval over that. An example of a multimodal RAG pipeline, that's a nice tutorial by, I think, a contributor on SingleStore's blog post, is building a multimodal RAG pipeline with Claude 3 and SingleStore. And so I think this was a few months ago, but this is actually a great example and a tutorial in case you or your developers want to construct something on your own using our library along with SingleStore as a database. Again, this basically just goes through the overall stack of we can pre-extract, index all the images and text content in your documents, store it as both text and image chunks, store that somewhere in a database, and then feed it to a multimodal model. Another example of maybe like a more advanced indexing approach here is graphs. A lot of people are interested in knowledge graphs. I do think some of this interest is maybe a little bit more motivated by hype than actual concrete use cases. However, inevitably, there's a lot of kind of interest in this idea to basically define an ontology over your enterprise data. And if you think about traditional vector search, it's primarily good at finding just like the most relevant bits or keywords of content specific to your question. But oftentimes what you want is not just like finding the nearest neighbor thing that's most relevant to your question, but leveraging domain context to then expand the retrieval to pull in more relevant information. This is what is basically what we call graph RAG these days, and leverages the capabilities of knowledge graphs to explore domain-specific relationships from existing entities, pull in more information, and help the end user basically get back a more comprehensive result that's rooted in kind of like more enterprise information. So this is something that we have like open source tooling for. Would encourage many of you to try it out. And if you're interested in contributing integrations for different types of databases or different types of algorithms and techniques, let us know. This is just an example of an existing graph RAG algorithm that we implemented. There's a paper by Microsoft called graph RAG. It's not the only way of doing graph RAG. I think graph RAG is just like a general concept, but this specific approach basically takes in a set of source documents, splits them into chunks, finds overall communities between these chunks and finds basically like summaries of these communities. So then when you do retrieval, you find like the sub-communities that this retrieval is relevant to, and you basically pull in all the context within these like community chunks. And the third piece of maybe more interesting indexing that I've seen is some way of like combining your unstructured and structured data. So hybrid vector search plus SQL. I actually floated this idea, I think, last year at the previous like SingleStore Now conference, and I'm pretty sure it's possible with SingleStore too, because basically the idea is that more and more query interfaces these days are like it looks a little bit more sophisticated than just like launching a natural language embedding against like a vector database and getting back a top K result. SQL tends to be a pretty expressive language to then allow you to specify like different types of filters, conditions, those types of things, and joins. And it's a very interesting approach to basically combine the capabilities of vector search, where you can do semantic search over unstructured text with structured filtering capabilities. So I've seen some examples where we've created this notebook where you can basically combine the syntax of SQL with unstructured vector search, giving you the best of both worlds. So if your data is semi-structured, it has both an unstructured text blob as well as like structured annotations, you can launch these types of queries and get back more interesting, precise results than doing either of them independently. This, I think, is an example from PG Vector, where you can see the SQL statement is like select text from blah, 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 where page label equals this. And then you also order by embedding with a special operator. And so it's almost like you inject the embedding in the SQL statement to also do semantic search. So an example like this, is generally something I'm very interested in, because at a high level, it means that you as a developer can simplify your stack somewhat, use a single source of truth as your database, and combine unstructured and structured data. We, at the LlamaIndex side, are building Llama Cloud, which is an end-to-end production-ready RAG platform. You can pick, your favorite data source, whether it's Microsoft SharePoint, S3, Google Drive. Pick your favorite vector database, whether it's SingleStore or something else, and then you can basically get the following benefits. I just listed like 5 to 6 different techniques. If you don't want to think about that, we can basically help you get stuff up and running, build a multimodal RAG pipeline over your PDFs very easily, and then also give you state-of-the-art performance and QA performance over your data. The next piece here is on agentic reasoning. Naive RAG, so far we've mostly talked about like data, right? Data indexing, parsing, retrieval, but we still haven't talked about agents. So the main limitation of any of these RAG pipelines so far is that they're not very good for questions that aren't pointed in nature. By pointed questions, I mean something about like a specific piece of context. So if you ask like a summarization task, like, give me a summary or a comparison of like these 2 entire documents, or you want to compare like 2 resumes against each other, ask like a multi-part question, or solve like a general research problem, naive RAG is not going to do well for that. If you think about how semantic search or top K search works, that's just not what it's built for. So the answer to this is to basically add agents on top of your RAG pipeline. And we call this agentic RAG. We think there's different types of architectures, from simple, more constrained architectures to more advanced agentic architectures. There's stuff like you can do a simple router that will take in input a set of choices and decide what choices to follow given an input. It's like a simple prompt that you can basically construct yourself. There's emerging support for stuff like tool use and function calling, enabling LLMs to actually interact or make API calls to external services. When you combine combine all these things together, you basically get a full agent system. And there's like full agent systems like React or Tree of Thought or LLM compiler. And some of these like new research papers that are coming out combine a lot of these components into a fully autonomous agent, so to speak. I think the ideal is that everything becomes like a fully autonomous agent in the future. I would say right now, most people aren't able to get there in a way that's both cost-effective, reliable, and performant. And so, most people probably build somewhere in between, leveraging some of these like LLM function calling modules, memory modules, composing something that's a little bit more constrained and use case specific before generalizing into higher level agentic architectures. The end result, though, if you're able to layer on an agentic reasoning layer on top of your data, is you're able to build like a personalized QA system that's capable of handling just very complex tasks from the user. Because instead of just taking in a question and directly feeding it to a vector database, by feeding it to this agent reasoning layer first, we're able to process that input in a much more sophisticated way through, again, query planning, query decomposition, tool use, and reflection. I talked about this for a bit, but yeah, there's a difference between something that I call a little bit more constrained as an agentic flow to something that's a little bit more unconstrained. And in the end, right, like what is an agent? No one really knows. An agent is basically just whatever you define it as with just some program that you write with LLM calls in the loop. That's like my general definition. It's probably the most general definition you can have. If it has 0 LLM calls, it's probably not an agent because you're not using GenAI. But if you're using GenAI, it's probably an agent. So given that definition, there's a wide variety of different architectures that you can build. Something that's more constrained in architecture basically just means you're not using the LLM for it's like too much throughout the entire application. Like you're not using it for loops or just like feeding stuff back to itself. You're maybe just like defining your own if-else statements, but using the LLMs for routing, maybe a little bit for reflection, for synthesis, so on and so forth. An unconstrained flow is something where you're really just using the LLM to automate the entirety of decision making. Instead of you defining if-else statements or while loops, you're letting the LLM just figure that out. A very general way you can think about this is the OpenAI Assistance API or the React loop, where you just give this agent like a set of tools. Instead of you as a human defining how it should use these tools, you kind of let the agent implicitly figure it out given the task at hand. Overall, I think there's a lot of beauty in this type of architecture. It's way more simple, it's more expressive, and if it works well, then you can basically just generalize it for a lot of different types of use cases. And we do see people do this. I mean, honestly, for like a limited set of tools, like 3 or 4, most LLMs these days are pretty good at just that general reasoning loop to solve that task. But if you're trying to build something a little bit more sophisticated, then the more unconstrained flows tend to be less reliable, fall apart. And so we see more interest in the user being able to inject some like domain-specific or use case-specific information. We at LlamaIndex are going all in on agents. We were known as a RAG framework. Ideally, this year we're known as an agent framework. And so we believe an agent framework should have the following properties. We want every kind of like agentic system to basically be event-driven, to be composable, so you can compose agents on top of each other and basically build modular bits before building higher order bits. Flexible, so you can write whatever Python code you want, and maybe soon to be like TypeScript as well. But basically whatever code and just like have the flexibility to like define the LLM calls as you see fit. And we also want it to be debuggable, observable, and easily deployable to production. So if you haven't already, check out LlamaIndex workflows. It's a base layer of abstraction where it's a very low level of abstraction. You just define a Python class with a set of different steps that you want this agent to take. You can literally do whatever you want in these steps, whether it has LLM calls or not, and then you can compose them into higher level workflows. It's kind of like Airflow or Temporal, but for agents. And I think I'm starting to run out of time, but just to conclude this is, besides like the agent like architecture and just like different types of reasoning modules you can inject, the part that we're really interested in is honestly like what are some of the use cases that enterprises are building with agents. There's a lot of different types of verticals. For instance, there's like coding assistants, there's like outbound sales, there's like marketing, content generation, internal report generation, data analysis, visualization. I think we care, just given our nature, right? Given the stuff that we're building, we like PDFs, we like documents, and so what can you do with them? I think one of the top use cases that we see actually throughout a lot of companies is report generation. So not just chatting over your documents or getting back like a chat response, but actually generating like a PDF, filling in an Excel sheet, generating just like figures, tables, and so actually automating more and more of the production of knowledge work as opposed to just like the synthesis. We're super excited about this, and we have a few different examples already to basically help users build like multimodal reports over some sort of like incoming data, build like financial reports given some bank of context, fill out questionnaires given, again, some bank of context. And we have like the agentic architectures for you to leverage both Llama Cloud as the data source for retrieval, plus the agentic orchestration to build these sophisticated outputs. But there's a lot more to come. And I think especially as we look at more use case specific things, there's a lot of opportunities to basically just continue enabling agents to produce more sophisticated, higher level outputs, again, as opposed to just like a simple chat response. There's also customer support. We have an example repo for that. There's a lot of AI startups that are doing customer support these days, a lot of money in customer support. We're still kind of doing this from a more exploratory perspective. So feel free to check it out if you use our abstractions. We'll love to get your feedback. But we want to, again, provide the developer tools to enable you to build your own customer support agents. So yeah, I mean, the concluding note here, and I'll skip the last section, which is just like on full stack deployment, is agents are very interesting. You can definitely leverage them for just like more advanced decision making over the inputs. And what we're especially interested in is not only kind of like, can they do things in a fully autonomous fashion, can they do things autonomously and also save the end user time? So that's why we're interested in not just agentic reasoning over the inputs, but also the decision-making, output generation, and figuring out how to help you guys as like developers build agentic architectures that are reliable, robust, and you can also do it very quickly. So thank you.